Thank you for coming to our talk, and we're going to be talking about some of our recent work around the layout system as well as text view to build a typography component that meets a new design system that we have at Pinterest. So my name is Thorben. I work on the commerce team where we make pins buyable.
My name is Wang. I'm from Pinterest core experience team. My daily job is to make sure Pinterest application are running faster, stabler, and also easy to develop with.
Since maybe not everybody here is familiar with Pinterest or how it works, and later on you might find the fundamentals interesting, so let me just share how it works so you have a better idea about the pieces that we're talking about later. So Pinterest is really all about images and visuals. A pin centerpiece is an image with a description. And here you can see, for example, in the top right, a share, which would be inspiration for maybe some new home decor. Or on the bottom left, some inspiration for a wedding. Pinterest has three key parts, which is discovery. Here you see the Explore tab, where we highlight boards from other people on the platform. But you can also use search to find things, for example, to build a wood wall in your house. Once you find a pin, again, it's very much centered around the image that you like. You can save it and then later revisit it in the board with all the other ideas that you have collected. And this staggered grid view here is a very popular view within our app, both in search results, home feed, or if you go to a board. So now that you know the fundamentals about Pinterest, let's get started with the main part of the talk. We have a design system that was started about a year ago, and two parts of that is, one part is the layout system and the other part is a typography component. And today we'll be talking about those in detail as far as building the blocks that in about a month the rest of the company will use to bring our Android app up to this design standard. So design system was put in place because many large products exist again across multiple platforms like web, iOS, and Android. And the different components may have been designed by different designers as well as implemented at different stages of the company. So they may not be consistent. And that may or may not be a good thing. At Pinterest, we think it should be universally across all platforms. So the design standard was put in place in order to scale design as well as engineering to provide the consistent experience across all platforms. And two of those things, so the design system is based around metrics, layout, color, and unified typography. And we'll talk about the layout part as well as typography. Here you can see the iOS app, which shipped a month ago with the new Brio system. You can see it's a very clean, very image-focused, and focused on the image as well as the text. So for the layout, the core piece is a grid on which everything gets laid out between columns and gutters. And the designs or all the components are always laid out to one of them. We don't think about devices anymore based on the resolution, but rather how we group them. So a small device, a medium device as far as a phone, a tablet, and then a large website. So that across them, they will all look the same. For this, we have a new unit called Boints, basically Brio plus points. And it scales differently based on what device, what classification the device has. It can scale horizontally and vertically differently. You can see here, for the first two, it's the same, but for the tablet size, it scales larger in one direction versus the other. And the last piece are the specs and how they're provided. You can see, again, the image is basically lined up on the gutters, and the units are provided both in points and in certain instances, either in DP, which is a point in the end, for the other platforms like iOS or web. The second part is typography. So normally when you get a spec, it's always in a font size. And between different designers or maybe between different products, that title might not have the same font size every time. So we wanted to make it easier for both design and engineering to just have either text or display and 5 different sizes for them. These will also then behind the scenes scale to whatever they should be for the specific device classification. And since Pinterest is all about text, images and the text, they wanted to put more emphasis on grouping the text closer together to make it look more a concise building block. So for that, we have aligning, which is the line spacing. So basically, you can decrease it to make the text look more compact. There's also tracking, which is the spacing between letters. And there's word spacing, again, to make it more compact between the words. And the last piece is auto-fitting. A lot of times, we get a design for a product in English. And so something like order history might work, but then next week we'll get a task from the translation team says, hey, this Bestellungsübersicht doesn't fit, and we get the ellipsis. And ideally we want to avoid this and not make it a burden for either design or engineering to really account for that and have special casing. So we want to have a text component that automatically goes down at max 2 sizes and only then falls back to the ellipsis. So now that we explained the two parts, the layout and typography part, Linda's going to take you through how we implemented the layout part.
All right, thanks, Thorben. So now we are aware of the requirements of the design. Let's dive into the layout system and see how it is realized by using Android default inflator in an innovative way. So there are two key elements in this new design, which is Braille point and then the grid system. So first, as we all know, a regular visual application contains a set of functional screens, and each functional screen has a number of graphical objects in it. We use length unit and layout classes to define the relationship of those graphical objects on the screen. Here we create a new unit of measurement called Braille point. This is designed to be independent from device sizes and platforms, because one Braille point will be translated into different number of DPs on devices with different resolutions. So beyond the Braille point, we also create a grid system. It has 12 columns in gray, surrounded by 13 gutters in white. The graphical objects will be aligned only on the gray columns. The principle of this design is to focus on the content while ignoring the subtle differences among the devices and platforms, so we can drive users' attention more into the core content. So if you look at Braille point more closely, here's a map explaining how one Braille point is translated to different number of DPs on different screen resolutions. So the first column is the smallest screen width in DP. If you are familiar with how Android manages resources for different resolutions, those are actually the names of the resource folders to store the XML properties for each resolution. This roughly represents the device category, which is displayed in the second column. So still not clear, the third column has some concrete examples. So in the last two columns, as the device window size increases, so does the number of DPs in a Braille point. We distinguish between horizontal and vertical because objects start to look too far apart vertically while the screen gets bigger. So here is an example of a design composition on a 320 by 480 device. We chose this as a target resolution for design because most of the devices fall into this category. On the right-hand side, it is a pin representation with the descriptions and pinner information. So the designer will only work with the Braille point and DP to define the spaces. The red ones are defined in Braille points, and the blue ones are defined in DP. With the map we just talked about, this will automatically scale to the devices with other resolutions. So the gutter width always has fixed number of Braille points, which the column width varies for Braille grid. Braille grid is the second key element of this design. The whole Braille grid will look proportionally consistent on different screen resolutions. So as you can see, the gray vertical lines represent columns, and the white vertical lines represent the colors. So we only align elements on the columns and use gutters as separators. On a bigger screen resolution, the graphical content will require more space than the separators. So this way, the system always keeps users' attention on the graphical content. So here is an example of how the home feed will look like in a grid system on a Samsung S5 device. By using those 4 units listed, we can put the home feed onto the grid and make it look very similar on all the platforms on the resolutions. So on the right-hand side, in the home feed, there are 2 vertical groups of pin images. The distance between them is 1 gutter. So if we put the same home feed onto a tablet, it will look like this. So there are 3 vertical groups of pin images, but the distance between them are still 1 white gutter. If you see the 2 circles in blue, the pin image acquires 6 columns on the phone and 4 columns on the tablet. The vertical distance between the pin images is always 10 Braille points on each of them. And the detail spacing inside the pin representation are also the same. So for example, the bottom margin of the pin description text are always 1 Braille point on both of them. So let's put it on one more device and look at them all together. So on the left-hand side, it's an iPhone 6. As you can see, the experience on those 2 phones are very similar. And it's not too far away from the experience on the tablet. So actually, this is what we want. With this design, we can offer the user a universal experience to discover incredible ideas across multiple platforms. Okay, let's talk about how did we implement this on Android. So since most of our layout resources are already defined in XML, the first approach naturally came into our mind is to define a custom attributes to support the new Braille units, namely Braille points, column, and gutter. And we will mainly use those attributes to define the vertical and the horizontal spaces between the objects. More specifically, to define height, width, margins, and paddings. So in order to put an object onto the right column index, we just need to specify those spaces correctly on the views in the entire hierarchy. So let's look at an example. So there's a vertical list view. Most of the elements are grayed out except one of them. The list view is a relative layout. The list view cell, which is not grayed out, is a relative layout with a text view and a switch button inside it. So we want the relative layout to take the full length of 12 columns. And the internal text view should take 10 columns. So let's look at it more closely. So as the XML specifies, the 2 rectangles in blue represent 1 gutter on the left and right margins of the entire cell. And the rectangle in green represents the width of the entire cell, which is 12 columns. The 2 rectangles in red represent 1 Braille point as the left and right paddings of the text view. So, okay, let's look at how we implement this custom attribute approach. So Android system doesn't know those Braille attributes at all. In order to translate those Braille attributes into actual pixels at the runtime, we set an inflator factory into the default inflator as a hook. So right before a view is created by the default inflator, the method onCreateView will be called. At this moment, the attributes of that view is available, and we are able to parse out the Braille attributes save them, and apply them back to the view once the view is properly inflated by the default inflator. It is simple, right? Let's look at other perspectives of this approach. So first, if multiple views have the same Braille attributes, and we could also put those attributes into a style, and this is supported natively by Android. Since the Braille attributes are all strings, and it's easy to make mistakes, and the custom attributes we added won't be validated by the Android lint tool. So we created a custom lint rule using the Android lint API to also validate the Braille attributes. Performance-wise, there's a little extra work added on view creation to only take the custom attributes. So far this solution looks good, but we also encounter problems. First, the default inflator factory can only allow one custom factory. While we use it for our Braille attributes, we couldn't do other customizations. This quickly becomes a problem for us since we also want to use a third-party library for typography. And that third-party library also requires its own customization for text view with the same approach. Secondly, the custom attributes could still be confusing with the Android default attributes. For example, Android requires the Android layout width mandatorily. So even if a developer sets the Braille layout width, she has to set the Android layout width as well, because Android lint doesn't understand the Braille attributes, and this is very confusing. Lastly, the new Braille units couldn't be defined as dimensions. For example, those three definitions are not possible since Android only accepts the built-in types like DP, pixel, or SP, etc. So let's check if we could solve those problems by using alternative approaches. So first, we can always create views in the code with Java directly, since the internal Braille conversion functions are available. Although this is more efficient than inflating from XML, but it's not as descriptive. And there are lots of boilerplate code you have to write. So any other approach? Yes, we could use Anko. So Anko is a library to make writing Android code very easy and fast. It is a domain-specific language to do Android UI creation in code, and this is written in Kotlin. Suppose you already know Kotlin, the key feature to make this possible is the class extension. It solved some of the problem we encountered. So let's look at an example. How do we create a view with Anko? So this is a vertical linear layout with one text view and one button. There are some Braille attributes we need to specify for those components. The text view has padding on the left and right, and margins on the left and right and top. The button also has a top margin as 10 Braille points. If you look at it more closely, margins and paddings are set to the right place. Does it look familiar? Yes. So writing those code in Anko is very similar to defining them in XML. And it's more efficient because those Anko code will be translated into Java directly. It's very easy to use and super flexible to extend. Most XML attributes are defined in Anko DSL already. But if you need something new, you can always add it by yourself. So with that, I'm going to turn it back to Thorben to see some magics in typography.
Thanks, Lin. So what do we mean by typography? It's how the text look and how it's defined in the design system. It's so that different designs doesn't have different sizes and introduce inconsistencies into our application. It's so that it's easy for both the designer as well as the engineer to go from the initial mock-up to the final product being shipped. So the goal is to create a custom text view that basically has all the functionality specified by the design spec, and it's really easy to use. For text sizing, we want to avoid specifying the explicit font sizes. So in blue, you can see whatever font size is supposed to be for the different device classification. So instead of specifying the font sizes directly, we go and define 10 text styles, text and display, and then extra small to extra large. So those are the only 10 that will ever be in your design or should ever be specified on your text view. And obviously, we want to set this both programmatically, but in XML as well. So for the XML approach, so those are the different sizes, small to extra large and display. On the XML side, we defined a new attribute to reflect those, the text and display, extra small to extra large. And then in your XML, as you can see on the right-hand side, you can simply specify Brio size, display small. And it will set behind the scene the actual font size that is specified for that device. But we want to go beyond that with the leading, tracking, and word spacing. And there's a table that was initially designed and specified in the design spec as far as how a particular font size matches to different values for those three categories. So for leading support, or the line spacing, we're actually lucky on this one because it's a feature that's been supported in text view since API 1. It can be specified either as a multiplier, such as 0.8, which will reduce your line spacing, or as a value that's added to the current font size, so either negative or like -5, for example, to reduce it. And so on the right-hand side, you can see the top one is how text would normally look without modification. The second one spaced out a bit more. And the third one, which is more close to our design spec, closer together to give it a more condensed view. And you can really focus on the description of a particular pin. So leading support was easy. Tracking, which is the letter spacing. I was glad to see that there's some more typography support being added into the framework. So as of API 21, we can actually specify this on a text view directly as well. Again, on the right-hand side, you see the examples on how this actually affects the text rendering. Normal on the top, a little more spaced out in the middle, and more condensed on the bottom. But what about like below 21? We support 15 and above. So is there no solution? Do we just not do it for Android 4? I looked around and came across spans. Some other people proposed that it may be possible. And if you're not familiar with span, it's something for you to like change the appearance of your text with, or a particular part of your text. So maybe a link that you want a particular subsection of your text view to be clickable, or bold, or replace a Unicode character with an emoji. There's one more, scaling. So you can use the scaling to actually modify the width of a particular character. So with the scale expand, as I said, you can modify the width of the character. As well as injecting new non-breaking spaces, we can then effectively modify the spacing between the characters in a particular text view. So how does that actually work? So we have the original text on the top, and then we need to split apart the text and inject the non-breaking spaces. We can't simply call string.split because then we might not be injecting the non-breaking space at the correct index, since Unicode characters or something else takes up more than 1 byte. So for that, we use a break iterator and then use the character instance to actually correctly splice by character, and with the help from the break iterator, know the correct index between the characters. So in the last step, you can see the vertical columns here between the characters. Those are the non-breaking spaces. Once you have the non-breaking characters in there, you can then basically wrap them in a scalar expand. And at this point, you can then give it a particular value to reduce or increase the spacing between the characters. There's one more step. Based on how tracking works, or how it's also implemented in the 21 and above in a text view, is that at the beginning of the line, the space is only half because there's no character to the left of it. So we have to use the static layout to basically figure out which of those break-in spaces is at the beginning of a line, and then reduce it. So with this, we have the tracking support, and some way at least to maybe bring this to all our Android 4 users. The last part is word spacing, and this is not supported at all from the framework at the moment, but since we just came up with this span solution or figured out how to apply it properly, we can use it here again. In this case, we would use again a break iterator, but this time we use a word break iterator to find the spaces in between, and if it's a blank space, then wrap that within the scale. So we also found a solution for this. So how does it actually look? There's a little utility to play with. And so here we can see the letter spacing being applied. All right. First, the line spacing. This is for Android 5 and above. The letter spacing. You can see it's specified in the EM value. And then word spacing last, which uses the span. And then obviously you can also apply both at the same time, the letter spacing and the word spacing. For Android 4, again, line spacing works the same as on 5. Then we use a span for both letter as well as word spacing. And you can see it behaves pretty much the same. Now we just need to use the utility to actually overlap both. Jesus, internet. There we go. So we can use the utility to have both the text showing for 5 and 4. And as we modify the letter spacing, we can then find a matching value for the span multiplier. And we can also apply the word spacing, and you will see they're almost moving in sync. They don't overlap exactly, but it's pretty close. So I was pretty happy with this solution. So now that we have leading tracking and word spacing support, auto-fitting support is left. Again, this is really important for internationalization and not having to deal with these small differences in the length of a particular word. Only works for single line. We reduce by a maximum of 2 sizes, so if we start at text large, we'll go down to a small at most and fall back on the ellipse if it's really necessary. And how does that work? All we need to know for this is really the width, so either it's specified up front or after the first on measure, and then use a static layout to apply the same attributes that later would use for the text rendering in order to find a size that fits between or fits under one line. And in an example, actually, you're looking at the same order history, Bestimmungsübersicht. So as soon as we flip it out, it figures out that it needs to size it down. Cool. How about performance? Because the spans is pretty heavy. So for the tracking or letter spacing solution for Android 4, some benchmarking showed 2 to 5 milliseconds for a small piece of text. So this will definitely be a problem once we move to screens that are really text heavy. At that point, it might be worthwhile to consider moving this to the background thread in order to still provide the same functionality, or simply exclude it from Android 4. For the word spacing as well as the auto-fitting, that performance is pretty good. Pretty happy with, at most like 1 millisecond. And so I don't see a problem that impacting the rendering time or causing us to drop some frames. Cool. That wraps up typography. Lynn will talk about some other learnings.
Great. So we have talked about multiple approaches. We try to implement the layout system. So either by defining the XML attributes, or do it in Java directly, or even do it in the ANCO with an even nicer way. But there's still one problem we didn't solve yet. So remember this? This is a single access to the layout factory, which is impossible for us to apply multiple view or customizations. So let's see how could we solve this eventually? Thorben?
So we were already using calligraphy to use custom fonts and specify them in our XML. Because of that, as Lynn mentioned, we had a conflict because we needed our own layout from Flater and they had theirs. At first, we did a little hacky solution where we integrated with theirs, had a local diff that would get applied, but we couldn't have the Gradle dependency anymore, so any new changes, we would have to manually bring them back to our project. I looked, and maybe we could do it better. So we ended up building a generic layout inflator that we have hooks in specific places of the layout inflator. The ones we needed for Brio were both on the on-view created to extract the attributes, as well as to reapply them in the on-XML inflated. For the calligraphy, we wrapped their method that gets called from their own layout inflator in a little interface to also get just a call from when a view is created in order for them to apply or set the custom font. And then something nice or unique that came up during that work was I saw that, we can just look at a particular name that's being passed into the layout inflator and then return basically any view we want. So you could no longer specify your custom views with a package, just with whatever class name, and your layout inflator can actually return the right instance. The other case is, for us, we use an image library called Picasso, but we might want to experiment with one from Facebook called Fresco. We have learned it's much better, but it's a huge undertaking in our code base. So what's an easy, and the problem is that Fresco extends their own image view, which is not the case with Picasso. But with this, we can now have a hook in the layout inflation process to actually either return our current Picasso image view or the new Fresco one, and run an experiment with that and see how it really performs without making a ton of changes in our code base. And for the typography part, we can meet the demands at least for Android 5. Obviously, out of the box is best, so hopefully more typography support will be added in the future. The span is a hack that works quite well. And I think we have now a pretty powerful text component that can be adopted throughout our application and then extended in the future in case the design spec changes without having a ton of refactoring work. Spam, again, the performance, there's some impact, and we're going to see how that's going to really perform on a text-heavy screen. And then two visual tools that we used to make sure things are actually aligned correctly. One that Lynn built is an overlay on our application. It can simply be turned on and off globally, and it hooks into the window manager to apply the grid, so you can always see that all your components are actually lined up correctly and match it up with the mock-up. The other one is an open source library called Rhythm, and I used it specifically to make sure that the letter spacing from the text view as well as the one built with the spanning lines up. So with Rhythm, you can specify different grids that are actually applied on top of your layout. The only thing is you have to wrap your view within a Rhythm layout. And you have a little drop down, you can see indicate on the status bar that lets you switch between, for example, a 2x2 grid, DP grid, 4x4, 8x8, so you can see how things look. And that's it. Thanks.
That was a point landing. Where are your questions? Who wants the microphone first?
Hello. First of all, thank you for such great presentation. I have a very general question. Which tools do you use or may recommend for collaboration between designers and engineers? Do you know for sure these Brio points, like quick assets, whatever?
So the question is, what tool is used by the design team, right?
Yeah, for shared design to engineers.
Okay, we use Sketch internally, and then
there's also a web tool that we use. Basically, upload the sketch files to I forgot what the name is.
That's Zeppelin. There's a web tool called Zeppelin.
Yep.
So you can share the sketch files across the teams as well.
Yeah, we also use it. I just was wondering what's in Pinterest. Cool, thank you guys.
We're using normal tools as well. We use lots of third-party tools. Yeah.
Do we have more questions? Yes, we have.
So thanks for your talk. I'm curious about whether it's open source or are you going to make it open source or?
The generic layout inflator is already built and in a separate module, so that's just a matter of actually doing that. For the text view component, I also split that up already, so there's a base that basically handles all the calculations, and then there's a thin layer on top for the Brio part, where we look at our specific like Brio requirements that are really like not part of like how the letter spacing works.
Okay, thanks.
Just want to make sure, Thorben, your email address is Thorben@Pinterest. Could you switch back to, is it Pinterest or really Pinterest? Okay. Thought you might have possibly opted for a very special email address or so. Any more questions? That is not the case. Okay, thanks again, guys.
Thank you.